Hello my dear students, here we have a question from JEE Advanced 2025 which is from chemistry, chemical bonding based on molecular orbital theory. Okay, the question saying here is regarding molecular orbital energy levels for homodiatomic molecules, the incorrect statement is or. Okay, so this is multi-selective question. So out of these 4 options, which is incorrect one they are asking. Okay, so bond order of Ne2 neon diatomic molecule here they mentioned formed from the neon. So Ne2 mentioned and it is 0. Yes, this is correct or not? Yes, this statement is correct only. Na bond order for neon is 0 only. How we are saying this? See, atomic number of neon is how much? 10. So 10 means, so neon diatomic molecule we have now, so it means total number of electrons in this molecule is 20 electrons are there. So now we need to fill these 20 electrons in the molecular orbitals formed by the combination of these 2 neon atoms, so that when they are combining we will be getting molecular orbitals like sigma 1s, sigma star 1s right now, and next sigma 2s, sigma star 2s, then next sigma 2pz, then next sigma next after this we have pi 2p x equals to pi 2p y. Okay, so after that we have pi star orbitals, pi star 2px equals to pi star 2py, right, and the next sigma star 2pz. These are the orbitals we have. So totally if you fill this 20 electrons, 2, 2, 4, 6, 8, 10 over 10 electrons over 11, 12, 13, 14 over 15, 16, 17, 18, 19, 20. See, 20 electrons are filled na, all these 20 electrons. See, whenever we have 20 electrons, we are filling like this. So now what is the bond order formula? Bond order equals to half into number of bonding electrons minus number of anti-bonding electrons. See, bonding electrons are how many? See, 2, 4, 6, 8, 10. 10 electrons are bonding. So similarly if you count anti-bonding, the star indicates anti-bonding orbitals. If you count number of anti-bonding electron, that is also 10. So 10 minus 10 0, so 0 by 2 it will be 0. So bond order will be 0. So here we have direct trick you can remember. See, if we have 14 electrons, the bond order is 3. If we have 15 electrons, bond order is 2.5. If we have 16 electrons, it is 2.0. Like that, as number of electrons increases, decrease it by 0.5, so that you will get the answer. 17 electron, so it will be 1.5. 18 electrons, it will be 1.0. 19, 0.5, and 20 electrons, it will be 0. So what is the bond order for neon diatomic molecule? It will be 0. Yes, whatever the statement they mentioned, it is correct only, but they are asking about incorrect statement from the 4 options. So first one is correct only, so we need not to tick this. Okay, leave it. So next, check for the second option, that is option B. The highest occupied molecular orbital HOMO for F2 is sigma type. Yes, this HOMO-LUMO concept is very important, very easy also. See, what is that? HOMO means highest occupied molecular orbital for fluorine. No? So for fluorine, what is the atomic number of fluorine? Yes, for atomic number here it is 9. So we are saying F2 molecule. So it is formed by combination of 2 fluorine atoms. Therefore, how many electrons are there here? So total electrons are 18. 9 plus 9, 18 electrons are there. Now we need to fill these 18 electrons in the molecular orbitals formed by the combination of these 2 atoms. So when 1s orbitals are combined, we will be getting sigma 1s bonding, sigma star anti-bonding, sigma star represents anti-bonding, sigma 1s anti-bonding, like this. Next, when 2s orbitals combine, sigma 2s, sigma star 2s. Now after writing this, I will explain you what is HOMO, what is LUMO here. Okay, now after this we will be having what? Sigma 2pz, after this pi 2p x equals to pi 2py. So these are degenerate orbitals. Whenever we are writing with the equal symbol here, it means they have equal energies. Therefore whenever we are filling the electrons, you need to give one electron each, like following Hund's rule of maximum multiplicity, you need to fill the electrons. I hope you know that concept also. After this, what we have respect to anti-bonding, sigma star 2p x equals to sigma pi star 2p, x equals to pi star 2p y, and after this we have sigma star 2p z. So these are the orbitals energy order. So as I am writing like this, it means energy is increasing in this order. Okay, so which is having highest energy, this is the highest energy orbital. Okay, molecular orbital with highest energy in this molecule means you should say this is a molecule with highest energy. Okay, so now we have 18 electrons now. Yes, fill the 18 electrons, 1 2. Okay, so let me write it as a number only. 2 4 6 over, 6 electrons are over, 8 over, 9 10 over, 11 12 13 14 electrons over. Next out of 18 14 over, next 15 16 17 18 electrons are over. Yes, so now where do we fill the last highest occupied molecular orbitals are what? See, now HOMO means nothing but the orbital which is at highest energy. So highest HOMO, so name the HOMO says that HOMO, it means highest occupied molecular orbital. So which is having highest, which is the highest occupied molecular orbital here? So these are the orbitals which is highest occupied, right? So this is the highest energy orbital which is having fully filled electrons. So it means this is the HOMO orbitals for fluorine molecule. Hope it is clear. Now they are saying it is of sigma type. No, it is of pi type now. See which orbital it is? Pi orbital is a HOMO. Pi star orbital will be the HOMO for F2 molecule. So which is pi anti-bonding is a HOMO of this F2 molecule. Now that statement is incorrect. B statement is incorrect in the question. So you need to take that option B as incorrect one. And here if they ask for LUMO in the next exam, okay, so what do we mean by LUMO? This is HOMO, this is LUMO. So lowest unoccupied molecular orbital. It means we are writing orbitals like this now. The orbital which is unoccupied with the lowest energy, it should be the lower energy and it should be unoccupied. See, out of this up to here it is occupied. So this is the only orbital we have, right? So which is not occupied. So this will become its LUMO. So what is the LUMO orbital for F2 molecule? Sigma star 2pz. Okay, I hope it is clear. Now let me write one of this like orbital so that it will be more easy to understand. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. I am writing like this. Okay, so now I am filling electrons here and here, right? So now tell me what is a HOMO and what is a LUMO orbital for this particular like electronic configuration. So tell me, so this is the highest occupied molecular orbital now. So this will be becoming HOMO, highest occupied molecular orbital. Okay, so now what is its LUMO? The next one, see here we have the lowest, see out of these two which is having lower energy, sigma 2s is having lower energy na? So lowest, it means lower energy orbital which is unoccupied. See there is no like occupying things, no electrons present here and here, it means both are unoccupied, but which is lowest unoccupied? Yes, this is the lowest unoccupied, so this will becomes LUMO. Yes, so this is how you need to answer. Okay, so now the next question will be like this. What is the reason for color, appearance of color in case of halogens? What kind of transition is responsible for this color of these halogens? Like F2, I mean Cl2, Br2 will show some color now. So what is the reason behind that color? Okay, so if you know, you can write in the comment box. This is also JEE Advanced previously asked question. So based on that concept only, I was giving this question. Okay, you just give a try from your side and you can mention in the comment box. I will be looking into your answers. Okay, yeah. So now what we are discussing? Yeah. So here, so option B is incorrect. We need to choose that. The bond energy of O2 plus is smaller than the bond energy of O2. See O2 plus, see here whatever the trick I have told you, based on this we can solve. See they have given O2 plus and they have mentioned also O2. So O2 plus means how many electrons we have here? Oxygen atomic number is 8, therefore 16 electrons in the diatomic state. So here we have 16 electrons, here we have 15 electrons. See what I told you, if 15 electrons are there, the bond order is 2.5. If 16 electrons are there, bond order is 2.0. So it means more the bond order, we know more the bond order, more is the bond energy also, because more bond order, more stability, the stability for that molecule, so more is its bond energy. So I can say bond energy is more for O2 plus then this O2. Okay, so this is the order, but what they mentioned, bond energy of O2 plus is smaller than the bond energy of O2. No, that is incorrect. Okay, so this is also you need to choose. Bond energy of O2 plus is larger than the bond energy of O2 is the correct statement, but they given in the reverse, so that you need to choose that question, that option also. Hope B and C are incorrect, you need to choose that. So let us look into option D also. The bond length of Li2 is larger than the bond length of B2. Yes, so just tell me whether it is correct or not. See, if you calculate this based on this molecular orbital energy diagram, so you will be getting bond order 1 and 1 for both of them. So what is the bond order equation you need to take here? The order will be like this: sigma 1s, see for lithium, Li2 now, it means Li2 means atomic number for lithium is 3, so Li2 means like lithium and lithium combining to form lithium diatomic molecule, so total electrons are 6, atomic number is 3, so for 2 atoms are there here, so bond total electrons are 6. So you need to fill sigma 1s, sigma star 1s, next sigma 2s, sigma star 2s. These are the orbitals you need to take for this. So 2 electrons, 2, 4 electrons, and here 2, 6 electrons. See, bonding, anti-bonding cancelled out, so we are remaining with 2 electrons in this bonding orbitals. So it means 2 electrons means what is the bond order? If we have 2 electrons, see, half into bonding electrons are 2, anti-bonding are 0, so that we are getting 1 as a bond order for Li2. Okay, if you similarly do for B2, see, B2 means boron atomic number is 5, so B2 means 10 electrons are there in total, so 8. After this we have pi 2p x equals to pi 2p y, this is the orbital we know. Okay, so after this 10 electrons means 2, 4, 6 over 8, 9, 10. See, this is anti-bonding, so this is also cancelled. We have 2 electrons in bonding, now pi bonding. Okay, so it means pi bonding 2 electrons are there, means again bonding 2 electrons, anti-bonding at 0. So bond order again 1. Hope it is clear. So bond order 1 for both of these B2 and Li2. So now in this case, how can we say? What is the correct explanation for this? Yes, see, we know basically, we know lithium and boron both belongs to same period elements now. So we know from left to right what happens from as we moving from S block elements to P block elements. What happens? The bond, atomic size decreases. It means lithium is having larger size than this boron. Therefore, larger size, so larger radius and greater will be the bond length for lithium, so that lithium bond length of lithium is more than this bond length of this B molecule, B2 molecule. Hope it is clear. This statement is correct only. So A and D are correct, B and C are incorrect. I hope it is clear. And one more question I am giving. So what is the type of bond present in B2 molecule? See, I told you bond order for B2 molecule is 1. So now what is the type of bond exist in B2 molecule? Similarly, what is the type of bonds exist in C2 molecule? These are the homework questions. You can try and write in the comment box, so that it will be clear your concept, and also it will make me to feel satisfied for my explanation. Thank you for watching.